Okay, question number 37. Coleman noticed that various combination of nickels, which is about 0.05, and dimes, which is 0.1, could add up to 65 cents. Let x equals the number of nickels, okay, and then y equals the number of dimes. Okay, what is the domain where y is a function of x? So we are writing like f of x is actually y in this case, meaning that that's a function of x, which is dimes. So we're gonna write the number of the dimes in terms of the nickels to give us 65 cents, and the total value is 65. So ideally what we have here is we do have the possible value of nickels. In other words, the domain is gonna be, in this case, domain will be possible. I'm gonna do possible being the key word to describe the domain, the possible values, okay, of x, which in this case represent number of nickels. Okay, so sometimes you can have 10 nickels, sometimes you can have 1 nickels, it depends. So let's write the equation. Well, if we have the equation, let's say y is how many the y is dime, so 0.1 times y plus 0.05 times x should be 0.65 cents. So to make it a little simpler, let's multiply everything by 10 or by 100, and then we get 10y is equals to 10y plus 5x is equals to 65. Now if we want to rewrite this one in slope-intercept form, we have minus 5x minus 5a, and then we get 10y is equals to minus 5x plus 65, and then we divide both sides by 10, and then we get y is equals to negative 1/2 x plus 6.5. Now this is our function. Based on this, we just have to figure out the one combination that gives me even number of dimes, because I can't have half a dime, because half a dime is not part of the solution. So we can try a couple of these ones. So let's see the ones that has 0. For instance, the first one has a 0. So if I plug a 0, I get 0.65 number of dimes. That doesn't make sense. So anything that has 0 should be excluded from this equation. Literally, like for instance, in this case, this is out and then this is out because they both have zeros. So if you look at it, 0 plus 6.5 is not going to work. So this leaves me with B and C. So B has 1, 3, 5, 7, 9, 11. So B doesn't have even numbers from what I see. So let's go ahead and then plug an even number and then see if we have right answer. 2, for instance, for x. So when we plug 2, negative 1/2 times 2 plus 6.5. Now when we do this one, we get negative 1 plus 6.5, which is going to be negative 5.5 dime. Again, this doesn't make sense. So we're going to be, this doesn't exist in terms of the dime list. So ultimately, based on these two choices, B is out, and then this leaves me with choice D. Now we can try each of them, and then that should give me a reasonably countable dimes, number of dimes. Let's try 1, 3, 5. Well, if I put 1, I get negative 0.5 plus 6.5 would get 6. When I put 1, I get 6 dimes. It makes sense. You see, 1 dime, 1 nickel and then 6 dimes makes 65 cents. It makes sense. How about if I put 3? 3 would be negative 1.5. When I put 3, then negative 1.5 minus that 1 would be 5. So 3, this is going to be nickels. These are going to be dimes. 3 nickels and 1 dime. The next one is 5. 5 is going to be 2.5. Negative 2.5. When I take out 2.5 from this one, I get 4. And then that would give me 65 cents. So based on this one, we can try 7, 9, 11 and 13. 7, 9, 11 and 13. Let's go ahead and then try 13. 13 divided by 2 is going to be negative 6.5 right here, negative 6.5 plus 6.50. So I can just use what, 13 nickels, and then I get 6.5. Perfect. 11 is going to be 1 less than that one, so it's going to be 11 negative 5.5. Negative 5.5, when we take out there, we get 1. So 11 nickels and 1 dime. When it comes to 9, negative 4.5 and 2. And then when you put that, 3. So these are the different combination that gives me. So remember, it's all about the linear equation and then finding the domain that makes this word problem valid. So based on this one, the correct answer is D.